Welcome back to this lecture. So in today's class, let's start with a deal now. So I would say you should pause this video, give yourself like 10 minutes to solve this question. Welcome back. Now let's see how to solve these questions. Let me start with the first question that we have. So the first question that we have a quadratic, equation right there. And then how can we solve for this quadratic equation? Now, the first thing I'm going to do is that I am going to look for two numbers that if I add those two numbers, I should get 4. And then if I multiply the same two numbers, I should get 8. Now, I want you to think about those two numbers, if you can find any. Now, if you think about those two numbers, we cannot really find anything in the real number space. So what I'm going to do now is that I am going to use the quadratic formula because it's not easy for me to get those two numbers. So the best thing I could do is to use the quadratic formula. So the first thing I want to do is to identify A. So my A in this case is going to be 1. This is going to be my B. My B is going to be 4. And then my C is going to be 8. And then remember your quadratic formula is x is equals to negative b plus or minus square root b squared minus 4ac. And then I'm going to divide that one by 2a. And then all I have to do is to substitute everything that I know. Now in this case, what do you notice? My x stayed the same. My b is 4 plus or minus. I have my square root. My b is 4 squared minus 4. My a is 1 and then my c is 8. And then I'll divide everything by 2. Then my a is 1. And then if I simplify this further, and then I have this one to be x is equals to negative 4 plus or minus square root. And then if I simplify what I have inside that square root, I have 16 minus 32 divided by 2, because 2 times 1 is 2. And then if I simplify this further, I notice that this is going to be negative 4 plus or minus, I have my square root. What is 16 minus 32? That will give me negative 16 divided by 2. And then if I go ahead and simplify this, you notice that my x is going to be negative 4 plus or minus. Now, what is the square root of negative 16? And that will give me, because I have a negative, I am going to put I. And then the square root of 16 would be 4. So I have this one to be 4i divided by 2. And then the next thing I'm going to do is to, divide each of the numerator by 2. So I'm going to say negative 4 divided by 2 plus or minus 4i divided by 2. And then if I divide this by 2, what do I have? I notice my answer will be x is equals to negative 2 plus or minus 2i. And then in this case, which means that my solution, I have two solutions. The first one is negative 2 plus 2i. And then the second one would be, my second one will be negative 2 minus 2i. What do you notice? They are conjugate pairs. These are conjugate pairs. So that will be the solution to the first question. Now, what about the second question we have right there? So for the second question we have is saying that we should find the vertex. Now, the first thing I want you to know is, if you notice, my a in this case is going to be 1. It's going to be positive 1. So in this case, my a is, positive 1. And if your a is positive, we know that that's just going to be a concave up. And then we're looking for this point right here. We're looking for this vertex. Right here, we're looking for this point. So, and then that point is going to be a minimum. So how do you find the vertex? So the first thing I want to do is to either graph this and then look at this point on the graph. It's either you graph this, you look at the point on the graph, or you could calculate this yourself. The first thing you want to do if you wanted to calculate this is by finding what is called the axis of symmetry. So what is the formula for the axis of symmetry? And that one is going to be x is equals to negative b divided by 2a. And then in this case, what is my a? My a is 1, and then my b is negative 10. That's my b. So in this case, I have my negative, and then I have my b to be negative 10 divided by 2 times my a is 1. And then if I do the math right here, I'm going to have 5. Which means since I have my axis of symmetry, is the same thing as my h. So which means my h is also 5. And now, how do I get the corresponding value for that 5? So all I have to do in this case now, I have to find f of 5. So I have to go to the original function and then substitute when s is equals to 5. So I have 5 squared minus 10 times 5 plus 11. And then if you do the math real quick on this one, you're going to get your f of 5 to be negative 14. So which means the vertex that I'm looking for, my vertex that I'm looking for, which is h and k. Now what is my h? My h is I've already calculated my h, and this is my k. So my answer would be 5 and negative 14. So what I want you to do is to graph this function. So what I want you to do is to graph this original function. Once you graph that original function, I want you to look at this point on the graph. So what I want you to do now is to look at this point on the graph and see if you are going to get the same thing right here. I am 100% confident that we are going to get the same thing. Now let's go ahead and see what we're going to learn today in class. And then in today's class, our learning goal is going to be that we are going to see the exponent rule. We are going to understand and use the law of exponent over the real numbers, and then we will be able to apply this exponent rule to expressions with more than 2 terms. And then the other thing we'll be able to do in this class is we'll be able to use the law of exponent to simplify the exponential expressions involving a real numbers, and then we'll be able to use those exponent rules to evaluate any expressions. And what are these exponent rules? So let's see this exponent rule. So we have this exponent rule right here. So I'm going to go over each of those exponent rules. So what do you notice? The first one is called the product property or the product rule. So for the product rule, this one means that if I am multiplying, if you're multiplying, so you can see in this case we're multiplying. So if you're multiplying, you are going to add the exponent. So if I am multiplying, I am going to add the exponent. If I am adding the exponent, I am going to multiply. So that's the rule. And then the second one is called the quotient rule. For the quotient rule, this one means that if you're dividing, you are going to subtract the exponent. So if you're dividing, you subtract. And then if you're subtracting the exponent, you have to divide. And then the other one we have is this power rule. So for that power rule, this one means that for my power rule, all I'm going to do is if I have a power, all I'm going to do is to multiply the exponent. So if I have a power, I'm going to multiply the exponent. And then we're going to see the rest of this property. So for this number 4 rule, this one means that if I am multiplying two things raised to a power, so all I need to do is to distribute that power. So let me put it that way. So it's kind of giving that power to each of those terms that I have inside the exponent. So we have that. And then the other one I wanted us to see is this one too. Just give the power to the numerator and then give this power to the denominator, just like that. And then there's another one that I want us to learn. This one is called the negative exponent. This one is called the negative exponent rule. This is the negative exponent. And then for this negative exponent, all we're going to do is, if you have a negative exponent, all we're going to do is to say 1 divided by, I am going to write that thing without the negative exponent. So let me repeat myself one more time. So you have a negative exponent. All we're going to do, we're going to say 1 divided by, I rewrite this without the negative exponent, just like that. And then we know that anything raised to the power of 1 is that thing. For example, myself raised to the power of 1 is myself. For example, Mr. Jibade raised to the power of 1 is Mr. Jibade. And then the other one I want us to know is any non-zero number raised to the power of 0 would give me 1. So any non-zero number raised to the power of 1 would always give us 1. Now let's see how we can apply each of these exponent rule. So for this, slide right here, I am going to do the one on the left, and then you pause the video, you do the one on the right. So for the first one, we have our product rule. So for our product rule that we've seen, that rule says that if I am multiplying, what am I going to do to this exponent? I am going to add the exponent. That's the rule we just saw. As I said, if you're multiplying, you are going to add the exponent. That's what we just saw. And then if you are adding the exponent, you multiply, just like that. So in this case, am I multiplying? Yes, of course, I am multiplying. Did they have the same base? Yes, of course, they have the same base. And now, what do I do to the exponent? I am going to add. So I am going to add this 10 plus 7. And that one is going to give me z to the power of 17. Now, don't forget, they must have the same base. They must have the same base. This z is called your base. And this 10 is called your exponent. That's called your exponent. That's called your exponent. So if they have the same base and you're multiplying, we are going to add. Now, what about the second example? For the second example, the first thing I want to do is let me multiply the constant. So what is 4 times 5? That will give me 20. And then I need to multiply x squared times x, and then I know that x is the same thing as x to the power of 1. And then now see, what do I have? I have that I am multiplying, they have the same base, and I am multiplying. What should I do to the exponent? I am going to add. Now what is 2 plus 1? 3. Now what about number 3? For number 3, we are going to do the same thing. The same thing I'm going to do is I would multiply those numbers. And then if I multiply those numbers, what am I going to get? I am going to have 7 times 2 is 14. And then what is 14 times 3? That one is going to give me 42. So I'm going to multiply those numbers. It's going to give me 42. And then the next thing I want to do is that I know that this x has a power of 1. I know that the y has a power of 1. I know that the z has a power of 1. Now, let's take care of the x first. So I have x right here, x right there, and I don't have any x. In this case, there's no x in this case. So what am I going to do? In this case, now they are multiplying, so I am going to add. So I am going to add, and I have x to the power of 1 plus 2 is going to give me 3. And then the next thing I'm going to do in this case now, I have y. So in this case, I have y, I have y, I have y, and then I know that this y is y to the power of 1, and then this y is y to the power of 9. So what am I going to do to the exponent? I am going to add. So I'm going to have y, 1 plus 1 will give me 2, 2 plus 9 is going to give me 11. Now what about the last one? The last one, I have z. So I have z right here, and then I have z right here. So what am I going to do to the exponent? I am going to add. So I have z into 1 plus 6. That one is going to give me 7. And that will be the answer to this question. I want you to look at, my calculations very well. And I hope that this is right. And then it's now your turn to answer all of these questions. So I want you to pause this video, and then I want you to use, the same thing we've done on the left. I want you to do it on the right. I'll be looking forward, to seeing your answer. Now let's move to another rule. And then for another rule, this one is called the quotient rule. For the quotient rule, we just saw that if you're dividing, what should I do to the exponent? I am going to subtract the exponent. So the rule that I gave you, you're dividing, you subtract, you divide, you subtract, subtract, you divide. So in this case, this should be easy. So I'm dividing, they have the same base. What should I do to the exponent? I am going to subtract. What do I have? 8 to the power of 3. Now, what about the second one? The second one, I have a constant. So for that constant, I want to leave it like that. So I leave my constant like that. And then I have my x, and then I have x right here. They are dividing each other. So I am going to subtract. And then I have y. They are dividing each other. Then I am going to subtract. Then what will be my final answer? So my final answer to this question will be 4 over 5 x, and then I have my y to the power of 11, and then which I know that my x is the same thing as x to the power of 1. What about example 3? For example 3, first thing I want to do is I want to multiply these two numbers. And then if I multiply those two numbers, what do I have? I have this one to be 27, and then I divide it by 18. And then now what do you notice? In this case, I have a right here, I have another a right here. They're multiplying each other, so I am going to add those two because they are multiplying. And now this one is dividing, so I should subtract. So I should subtract that, and then I'm done with that. Then I have my b right here, another b right here, so they are multiplying, so I should add those two, and then I'm dividing that by 3, so I should subtract. And then let's simplify everything that I know. So if I simplify 27 divided by 18, that one should give me that one. If you simplify 27 divided by 18, that one should give me 3 over 2. So that one should give us 3 over 2 to the lowest term. And then I know that this one is going to give me 7 plus 6 minus 5. So this one is going to give me 8. This is going to be 8. And then I know that this one is going to be b to the power of 0. And then we just saw a property that any number to the power of 0 apart from 0 will give me 1. So this one is going to give me 1. So my answer to this one will be 3 over 2, a to the 8, and that will be my answer to this question. So what I want you to do now is I want you to pause this video, and then I want you to do the example that you have on the right. So go ahead and pause this video and do this example that you have on the right, and then I will be looking forward to seeing your solution. And thank you so much. I'll be looking forward to seeing your solution. Now let's see another rule. Another rule is called the power of power rule. And then for that power of power rule, we said that if you have, for example, we said if you have a to the power of m multiplied by n. So what are you going to do to the power? You are just going to multiply the power, or you multiply the exponent. So I'm just going to multiply the exponent. And that one, I said, if you have a power, you should multiply. So you have a power, you should multiply. So in this case, do I have a power? Yes, I have a power. So what should I do to these two? I should multiply. So I have x. 5 times 3 will give me 15. What about this one? So the first thing I want to do is to give the power to 5 and then give the power to this one too. So how am I going to write that? So I have 5 to the power of 3, and then I have my z power of 8 to the power of 3. So now what is 5 to the power of 3? That will give me 125. And then z to the power of 8 to the power of 3. So that one I just need to multiply. So I have my z to the power of 24. Power of 24. What about example 3? For example 3, the first thing I want to do is I want to simplify this so that it can be easier for me to solve. So first of all, you're going to give this power to 2, give this power to that, and then we're going to give this power to this one too. And then let me write that first. So if I write that, I have 5. Then I have this one to be 2 to the power of 3. Then I have x to the 4 to the power of 3. And then y to the 7 to the power of 3. And then now I am multiplying, so I need to multiply. And then the next thing I want to do is I want to give this 2 to this power. I want to give this 2 to this one too. So how am I going to write that? This one will be x to the power of 3 to the power of 2. Then I have y to the power of 5 to the power of 2. Then the next thing I want to do, I want to simplify. So if I simplify everything that I know, I have my 5. 2 to the power of 3 is going to give me 8. And then I will need to multiply 4 times 3 is x to the power of 12. And then 7 times 3 y to the power of 21. And then I need to multiply by x to the power of 6. And then y to the power of 10. And then now, what do you notice? I can multiply. What is 5 times 8? That's 40. And then, now what do you notice now? I notice that I have x right here, I have x right there, they're multiplying each other. So I should add the exponent, right? So I should add the exponent. So that will be 12 plus 6, 18. And then I have my y, they're multiplying each other. So I should also add the exponent. So if I add the exponent, this one should give me 31. And that will be the answer to this question. So I have done rule number 3. I would like that you pause this video and then you do the one on the right, because the one on the right says you do. So you do. I'll be looking forward to seeing your solution. Now let's go to rule number 4. For rule number 4, what is rule number 4? For rule number 4, this one is something that I just did just now. And that rule, let me remind you of that rule. That rule has said that if I have AB, they are multiplying each other to the power of n. So all I'm going to do is to give this power to each of that term. So I'm going to give that to each of that be to the m. That's all I'm going to do. So now for this one should be very straightforward. So I give this power to that, and then I give this power to that one too. So how am I going to write that? So I have my s squared to the power of 3, and then y squared to the power of 3. And then if I simplify this is rule number 3 now. So according to what we just did in rule number 3, this one will be x to the power of 6 and then y to the power of 6. And that would be my answer. Now, what about number 2? For number 2, I'm going to do the same thing. 2 to the power of 5, x to the power of 4 to the power of 5, sorry, and y to the power of 4 to the power of 5. And then I'm going to simplify. 2 to the power of 5 is going to give me 32. And then x to the power of 4 to the power of 5. I just need to multiply that. That will be x to the power of 20. And then y to the power of 20. Just like that. And then let's do number 3. For number 3, you notice that that one looks like it's kind of complicated, but it is not. So you just have to, all I'm going to do for this one is I am going to simplify the numerator before I, divide it by the denominator. So let's simplify the numerator. So simplifying the numerator, I am going to have 3. So for this power, I would distribute this power first. So let's distribute this power. So I distribute that power, I distribute that power. I give that power to each of those things that I have inside that parenthesis. And then, what do we have? We have 3 to the power 4, x to the power of 3, to the power of 4. Then I have my y to the power of 2 to the power of 4. And then once I have that, what am I going to do next? The next thing I'm going to do is I need to write down multiply by, so multiply by 5 x y 1/2. And then the next thing I'm going to do, I will divide it by 27 x y 3. And then let me simplify. So if I simplify this, 3 to the power of 4 is going to give me 81. And then divide that one by 27 because those are numbers, right? And then x to the power of 3 to the power of 4, that will give me x to the power of 12. And then this one will give me y to the power of 8. Multiply by 5, right? And then I have my x, y to the power of 1/2. This one you have to be very careful on this one. And then now we have x to the power of 4, y to the power of 3. And then if I go ahead and simplify this, if I divide 81 divided by 27, that one should give me 3, right? So that one should give me 3, and then 3 times 5 should be 15. So if I simplify the numbers, I should have 15. And then notice something. So on this end, I have s to the power of 12 multiplying s to the power of 1. So that will be x to the power of 13, right? And then I have y to the power of 8, and then y to the power of 1 over 2. And then if I do the math on this one should give me 17 divided by 2. If I add 8 plus 1 over 2, that should give me 8.5, right? And 8.5 is 17 over 2. And then I need to divide this one by x to the 4, y to the 3. And if I do the math, this one will give me 15. I'm dividing these two, so I should subtract. So I should say 13 minus 4. 13 minus 4 will give me 9, right? 9, yes. And then what is y to the power of 17 over 2 minus 3? And that one should give me 11 over 2. I hope I'm right. That one should give me 11 over 2. Make sure you check my calculations, and you are going to solve the one on the right. Now let's go to rule number 5. For rule number 5 is basically the same thing, but in this case now we're dividing. So all I'm going to do for this one is give this power to this one, then I give this power to that one too, right? So how am I going to write that? So I have a squared to the power of 6, and then b to the power of 3 to the power of 6. And then this is rule number 3. So my rule number 3 now, if I apply my rule number 3, that will be a to the power of 12 divided by b to the power of 18. Then if I do number 2, I'm going to do number 2 like that. So for number 2, I will have a to the power of 3, b to the power of 2 to the power of 8 divided by a to the power of 11. So for this one, I'll give the power to each of those and ones that I have inside the parentheses. So I have a to the power of 3 to the power of 8, b to the power of 2 to the power of 8 divided by a to the power of 11. So let's simplify. So I have a to the power of 24, b to the power of 16, divided by a to the power of 11. And now, if I do the math on this end, what do I see? A and A, they are dividing each other. So I have A and A dividing each other. So what should I do to the exponent? I have to subtract. So I'll subtract the exponent. What is 24 minus 11? 24 minus 11, that's 13. Then I have my b to the power of 16, and that will be the answer to that question. Oh, I forgot something. Oh, I forgot to put the power right here, so that will be wrong because I forgot to put the power right there. That will be incorrect. So I forgot that. So what is 11 times 8? That should give me 88. 88. Thank God I saw that. And then let's erase this real quick and let's simplify one more time. So let's simplify it again. So if I simplify that again, what is 88? So I'm going to do, I'm dividing, I'm going to subtract now. What is 24 minus 88? So this one should give me negative, right? Negative. I should have 4, and then I should have 6. Then I have my b to the power of 16. Yes, that should be the right answer. This should be the right answer. Now, what about question? You have to be very careful when you're doing this. You have to be very, very careful and be patient when you're doing this. So, let's do question 3. For question 3, on this one, you have to be careful, you have to be patient. Then on this one, give the power to each of them. So I have 4 to the 3, x to the 9, right? X to the 9, y to the 3, multiply by x to the 18, y to the 9, divided by 2 to the 3, x to the 12, and y to the 6. I just gave the power to each of those numerator and then denominator. And then this one, I have multiplied by 10 to the power of 2, x to the 6, and y to the 14. Now, let's simplify. So, I have 4 to the power of 3 should give me 64. And then 2 to the power of 3 should give me 8. And then what is 10 to the power of, what is 64 divided by 8? That one should be 8, right? And then what is 10 squared? 10 squared is 100. What is 8 times 100? That one should give me 800. And what do you notice? This one, you have x right here, you have x right here, you have x right here. They are multiplying, so I should add, right? 9 plus 18 plus 6, and you're dividing, minus 12. Then you have your y. I have my y multiplying. So y is multiplying, that's 3 plus 9 plus 14 minus 6. And then once I notice that, what should I do? Simplify all of them. So you simplify 800. And then x, what is, 9 plus 18? That should give me 27. And what is 27? 27 plus 6, that should give me 33. And if you subtract 12 from that, that should give me 21. If I'm right, that should give us 21. And then what is 3 plus 9? That should give me 12 plus 14. That should give me 26. Minus 6, that should give me 20. So this should give me 20. I hope this is right. Please check my solutions and let me know what you have. If it's different from that, and you do the one on the right. Now let's go to rule number 6. Rule number 6, which is called your negative exponent rule. A reminder about that rule is that if you have a to the negative exponent, all we have to do is to say 1 divided by, rewrite that thing without the negative exponent. So this one, I have a negative. All I need to do is to say 1 divided by n to the power of 10. Now I want you to focus on this example too. If you have like a quotient and you have a negative exponent, so you have a quotient, you're dividing into things, and you have a negative exponent, what I want you to do is to switch the numerator and the denominator. That's it. So just switch them. So what do you have? You have y over 5x to the power of, once you switch them, you are going to write the exponent without the negative anymore. So now we can apply one of the rules that we saw. So which means I will give the exponent to y. Then I will also give that exponent to the denominator. So if I simplify that, what do you have? You have y squared divided by 25 s squared. And that will be the answer. And then what about this one? For this one, you have to be very careful. Negative exponent, yes. We're going to switch this because we're dividing two, terms. And then if I switch that, I have 2x divided by 3y. Once I switch that, I write that exponent without the negative. I am going to give this to each of them, right? So which means this one will be x to the power 14, 2 times 4, 2 times 7, 14, y to the power 14, divided by 16, x to the power of 3, y to the power of 3. And then the next thing I want to do is I want to simplify. So 2 divided by 3, and then you simplify that, you are going to have 1 over 24. Then, or let me write it like this. I don't want to skip that step. So I don't want to skip that step. So on this one, I have my 2 right here. So this one is 2 to the power of 3, x to the power of 3. And then I'm going to do the same thing right here too, and right there too. So I have 3 to the power of 3, y to the power of 3, multiply by x to the power of 14, y to the power of 14, divided by 16, x to the power of 3, y to the power of 3. And now let's simplify. So if I simplify this, I have 2 to the power of 3, 8, x. What do you notice? We are going to add, so that's 17. And then this, dividing, subtract. And then I have my y. My y right here. What do you know right here? So my y right here is 14. You're dividing, subtract. You're dividing, subtract. And then on this end, don't forget, I still have 2 to the power of 3. That's 27. And then I still have 16, right? I still have this 16. And then if you do the math, what do you notice? This one is going to be 1 over 54, right? Because if you multiply 27 times 16, and then you see 8 divided by those multiplication, you should get 1 over 54. And x to the power of 14, and this one should be y to the power of, this one is negative 6, then this one should be 8. And that will give me 8. You have to be very careful on questions like this. Now for 7 is looking like what we just did. For 7, it's looking like the negative exponential. I'm going to delete this page, looking like that. And that will be the end of today's lecture. And make sure you watch this video to the end, and make sure you practice the questions on the right. And I will see you in the next class.